In this video, we're going to provide an overview of O-Calc Pro, talking about each of the individual panes in the main view, what each one does, and give a very brief overview of how do you work with it. In future videos, we'll talk in detail about how to use each individual function, the most efficient way to perform tasks, and shortcuts for doing various operations. So let's just take a look here at what we see when we open up O-Calc Pro. If you'll observe on the left-hand side, we see the inventory panel. This is a graphical representation in the form of a tree of the components that make up this pole and the elements on this pole. And what I can do is I can expand or contract so that, for example, I can see here's the pole. At the very tip of the pole, there's a pin insulator. On it, there are two spans. One is proceeding off at 0 degrees for 249 feet. One's going 180 degrees at 246 feet, and I can walk down the chain like that. And at the very bottom, I see the load case that's applied currently, which is an NESC heavy district, grade B, Rule 250B, Win 2007. And if I look at the bottom left, I can see an instant readout of the results that I'm getting for applying that load case, which tells me that my pole is in fact overloaded to the tune of 132, 133 almost %. Next to that, I see my schematic view, which shows me a side notional view of the pole. It also shows me a set of bars that show me my vertical capacity utilization, my ground length capacity utilization, and my maximum capacity utilization by % at each load centroid, so at each point where a force is applied to the pole, up and down the pole. And as you'd expect, the vast bulk of my load occurs at the two cross-arm points. Interestingly enough, if I look, I can see that there's a fairly large component of vertical load applied by this second item from the bottom, which turns out to be the secondary lines. So we could go in and look and see what the weight of those is. Across the top, then, I see my data entry panel, where whatever item I select on the left in the tree view, I'm allowed to edit it on the right. I have a tab for my 3D view, which is my view that shows me this item, shows me the pole. I see a compass on the ground so that I can figure out where things are. I see an arrow that tells me which way my worst wind is currently blowing and how many pounds per square foot. If I zoom in here using my mouse wheel, I can see that I'm deflected in the direction of the wind, which makes sense since the spans are essentially balancing each other out. And I can see my insulators. At the upper left, I have a heads-up display that tells me the compass direction that I'm currently looking with the camera. So I'm looking from the south to the north, essentially the north by northwest position. My current camera is at the height of 70 feet, so my camera is essentially 70 feet above the ground. This crosshair indicates that I'm looking down and looking straight ahead, and these bars here tell me my zoom level. If I press and hold my left mouse button and move left and right, I can essentially pan or rotate the pole. If I press the right mouse button, I can pan the camera left and right. Same as if I press the left mouse button, move up and down, I'm moving the whole camera up and down, whereas if I hold the right mouse button, I'm panning the camera up and down. And you can see that the pan bar, in fact, and track bar adjust. The wheel zooms me in and out. And if I ever get hopelessly lost, I can go to View, 3D View, Reset Camera, and it'll put me back to my default view. On the third tab, I have my Measurement tab, and this is a tool that allows me to use photogrammetry to, in fact, enter all of the dimensions of the pole in the event that I actually have a calibrated image available of the pole that I'm measuring. We'll get into that in the future, but it's an extremely convenient way to set all of the dimensions of your pole without having to go out and use a total station or without having to use a measuring stick. Finally, I have the top view over here, which shows me the general direction of all of my spans. So I have one large group of spans going to the, essentially north, and one large group of spans going essentially south. And finally I have my catalog view, and this is one of the most important views in the entire system. This is the list of pre-assembled components that I can use to build up a pole. Although I can build up a pole from scratch, it's much more convenient for me to use this catalog, and we'll get into that in much greater detail. So let's talk about how I could edit this pole if I wanted to change something about it. One of the first things I might want to change is just the overall line and lead of the structure. So if I go to my polar view, my top view, and click right in the middle, I can just say, you know what, the overall angle of this entire structure is 45 degrees, and the whole thing will rotate around. You see it changed in the top view. The wind, in fact, changed, as you would expect, and the pole rotated relative to the compass. I can do groups of geometric edit operations by saying, you know what, I want to set all of the spans going in a particular direction to 220 feet, and I want to set all the spans going in the opposite direction to 236 feet. And that's actually kind of useful in the event that what I'm doing is taking an existing exemplar pole and that's already been built and modifying it to match my conditions. So that if I've got a pole that's pretty much what I want, all I've got to do is edit it. I don't have to go ahead and build it from scratch. The way that's done is either in the primary view or in the catalog view. Simply right click on a pole and say create a new pole using this pole as a template. I'll go ahead and say that. Now what it's going to tell me, since we did a few edits, is that the current pole is not saved. Do I wish to save it? No, I don't. And now, boom, I've got a new pole that matches what this pole is. Now you notice it's a different pole. This pole only had a single cross arm, and it was a medium instead of a heavy, and so on and so forth. But if I go overhead and look, here's my pole. Now, let's say this pole is pretty close, but in fact I have an additional conductor that goes in the same general direction and is made of the same materials as the conductor is located on this cross arm, but it's on the tip of the pole. Well, simple enough. If I take the either one, doesn't matter, the insulators off this pole, and I just drag it and drop it onto the, or off the cross arm, drop it onto the pole, you'll see what it does is it smartly makes a new one. Now it realizes that it's on a pin insulator, so the only possible location it can have is the tip of the pole, and that's where it puts it. If instead what I did was I said, you know what, well, actually I don't have one available, but I'm going to cheat. I take the pin and put it up here, but I then select that item and I say, you know what, he's not a pin, he is in fact a spool. It is now possible for him to live on the side of the pole. So if I go to my 3D view, and you'll see what's happened, he has flipped over to the side of the pole. And I can move him down where he belongs. Now, that I moved that in that case on the 3D view, but I can move him just as easily from the measurement view. Now what I'm going to do is switch over to a different layout. All of the way that these panels are laid out on my screen is in fact under my control. I can take each individual item, I can drag him and drop him, I can dock him any which way I want. I can also hide and then restore items. I can take him and say, you know what, I'd really rather have him be on the bottom. Anybody who's familiar with Visual Studio will recognize that this docking is very similar, although it's slightly more flexible. Now, one of the things I